Okay, thank you. So I'm Frederic from Egaya. And in this talk, I'm going to talk a bit about the status of MathML in Chrome. So, well, mathematical layout is something really complex. And the original MathML specification was really huge. So the approach we followed since 2019 was to focus on a subset called MathML core, so that we can more easily manage it. We can better integrate it with the rest of the ecosystem. And one of the issues with the legacy MathML specification was also that it was lacking a lot of implementation details. The level of details was really bad. And by bad, I mean that, for example, the MSQRT element, the specification was just saying, okay, it's supposed to run the square roots. So with a bit of imagination, you can say that this redwoods tree is actually implementing this specification. So yeah, so that was the mandatory redwood metaphor. So now I'm going to talk a bit about well, I'm going to present a bit some demos, and in order to reflect the diversity of the Chromium community, I've decided to pick some demos coming from different cultures. So one of the first thing we can ask was, is it really necessary to have mathematical formulas? Can we just use words? So, well, to give an example, I decided I was preparing this presentation. I thought maybe I could consider the word problem by Flaubert, which is more or less as follows. So we have the number of Hegelians given for different time. When I joined Igalia, it was more than Chrome's version number. On October 17, 2021, well, if you counted the Hegelians by group of 2, you get 1 person left over, the same by 3. If you counted them by 5 or 7, you got 4 left over. And today, the number of Hegelians is still less than the capacity of BlinkOn's room. So the question is, what is the age of the CEO? But then I was discussing with Lauren yesterday, and he mentioned maybe this is a bit too difficult, so I tried to simplify this. Instead, I focus on a Chinese problem for the 3rd century that some of you probably heard about. So we have the same situation where we know the number of Hegelians on October 13, 2021, and we know the value modulo 2, 3, 5, and 7. And we also know that it is less than 210. So the question is, how many Hegelians were there? I don't know if any of you have any idea. Nobody? Okay, so 9? That's really small. When I joined Ikea, it was already 50, so yeah. But actually 9 is a good thing because 9 ends with digit 9, and actually all the solutions end with digit 9. So that's a good point. So I'm not sure I'm going to give the details, but my point is really that in order to explain this kind of problem and give the detailed solution, it's really difficult to give it only with words. So we really need to have some more advanced notations, which were, in that case, invented by Gauss for the modular arithmetic. Anyway, so the solution is 109. So you get the 9. And yeah, and it's actually exactly the version of Chrome where we expect to ship MathML. So yeah, so the status is that we got approval from API owners. The flag is already turned on in Canary, so you can already experiment it. And if everything goes as expected, we'll get native MathML support in Chrome next January. So as a quick digression, well, you can do like the ancient grid and verify that BlinkOn 17 and Chrome 109 are actually using prime numbers, which I think is an interesting property. Okay, so going back to the demos, so I'm going to talk about the tablet BM 85196. which is actually not a new Android device, but is this clay tablet that you can see on the picture, coming from the Babylonian era. And this tablet is interesting because it's one of the oldest problem we have, mathematical problem. So it's basically as follows. You have a pole of a certain length L is placed against a wall. Then its top end edge is shifted down by a certain amount, delta L. And the question is how far the bottom end of the pole has moved away from the wall. So again, this Babylonian problem is explained using only text, even uniform text. And it's also given the solution. But well, if you really given this to your high school students, how they would solve this is basically to start drawing some schema, then place different distances, and then use the Pythagorean theorem to express the solution with square roots and so on. So we really need this kind of schema that are currently rendered with SVG plus MathML. And so I think that's a nice thing. And I think that's something that we can now get on electronic tablets too. So another demo that I like is the problem from the Indian mathematician. So that's called the Chakravala method. And the problem is about finding unknown integers xy, satisfying this simple identity x squared minus n times y squared is equal to 1. You can find some example on this slide with different values of n. And you can verify these values, this solution with your JavaScript console, or you can try to find that with brute force search. But I guess what is really interesting for teaching purpose would be to actually have this kind of program, which an iterative program where you specify the value n, and you automatically get a detailed solution, the different steps of the algorithm with the detailed solution. So I implemented this with JavaScript, and it's generated mathematical equations. And an interesting point here is that the non-trivial solution for 109 is actually too big that you cannot check it in your JavaScript console unless you use BigInt, which I also thought was interesting. Yeah, so to conclude, the demos also have these formulas that were published by Gauss in the beginning of the 19th century. And these formulas well, show different aspects. So you can see they're using fractions, radicals, different function names, stretchy fences, large operators, and they use very specific spacing rules and script size and so on. So well, you have a lot of things to know about and in order to render this complex notation. So I guess that summarizes a bit the goal of this project, which is to be able, on the one hand, to render this kind of complex notations, and also integrate well with the rest of the web platform. So like I already mentioned, SVG, JavaScript, and I also used CSS, of course, to highlight the numbers. Okay, so that's all for these MathML demos. Hope you enjoy them. Now I'm going to move back to the achievements since May. We're using some of the information we already provided in BlinkOn 16. Yeah, so we have this roadmap that we published in 2019, which were a rough list of goals that we have for MathML, a list of tasks and list of features to implement. And in the last BlinkOn, we mentioned that, well, almost all of them were complete. We had some minor issues that we don't plan to fix in the next, in the first release, sorry. But the main problem that we mentioned and that we discussed in the previous BlinkOn was table support. It was really bad. We had some alignment issues and some line breaking issues too. So, well, now this was fixed, so it's good. We think that now things are ready. You can see this rotation matrix from the CSS specification. Yeah, so, and in the last BlinkOn, we also mentioned that there are other tasks that we are interested in. Again, the thing was that we think that most of the things are ready, but of course, there are always some stuff that we need to keep an eye on, like impurity or security. I'm going to give more details in the next slide. So one of the problem, the current issue is the lack of pre-installed math font on some operating systems. If you don't have proper math font, well, you can still render some simple math equations, but if you want something like what I showed with Gauss formula, you will basically get bad rendering, which is not acceptable, for at least for people who are used to tech, for example. So I have two good news on this front. So the first one is that Apple released last month. They released a new version of macOS, which has some proper fonts to run the MathML and the math equations. And also, there are some interesting discussion on the Noto-san math tracker, where some people were interested in implementing the math-related open-type features for this font. Yeah, so another thing that were reported by API owners during the BlinkDev discussion, so intent-to-ship discussion, I mean, was that documentation is, of course, really important if we want to release something and that new web developers discover things and want to play with this. So, well, we have done a big effort to update the documentations as well as the related data. So, for example, the browser compatibility data. And we wrote this gentle introduction to MathML. We also, of course, documented all the new math-related CSS features. But maybe the most important point is that we switched the documentation to use MathML core as a reference, so that users know that it is the one thing to use. And the legacy features that are still implemented in Firefox or in WebKit, well, they are clearly marked as legacy or deprecated or non-standard. Yeah, another thing that was raised by API owner was the security part, which is also an important one. So as you know, we have, for this proposal for layout, we have some DOM fuzzers that try to detect assertions or crashes. In the past months, we didn't get a lot of them, but we still are able to fix them. One of the DOM fuzzers is actually public, so we contributed some patches to make sure it is up to date with respect to the MathML core documentation, specifications, right? Then there is, so this is for DOM fuzzers, but one of the limitations with that approach is that some low-level APIs that are used for MathML are not really exercised by fuzzers. Well, at least it's really difficult to generate the proper things. Basically, you need to generate some specific Unicode code point for operators, for example, and be sure that you have the font data, the open-type fonts with the proper font data. So maybe it's a bit difficult to reach with DOM fuzzers. So one thing that we did was to actually rely on in-process guiding fuzzing, which allowed to more directly exercise the thing. But again, we didn't really find a lot of new crashes. The only report that we got was a bug for the open-type sanitizer for WAV2 fonts. And finally, we also imported some existing crash tests from Mozilla, and we verified that, of course, they don't crash in Chrome. So if you see the glass half full, I guess we can say that the MathML support in Chrome is pretty stable. We didn't get any new security crashes or whatever. But of course, if you see the glass half empty, maybe you can say that the fuzzing support or stuff like that is not good enough. So I'm happy to hear if you have any idea how to improve this for MathML. Well, there is also this discussion about compatibility, so CSS and HTML. For that one, we didn't make a lot of progress. So we have some things that are more or less stuck on Wing and CSS this working group discussion and Math working group discussion. There is also all this kind of thing about interpreting CSS properties like padding, border matching, width and height. We did some work for the specification, but sometimes there are still some inconsistencies with what we actually implement and what is in test. So that's something we still need to improve too. Okay, so moving to Impurity. So this is the result of the web platform test. Remember that when we began some years ago, there were not a lot of tests. Currently, there are 2,700, about 2,700 tests. Chrome has a pretty good score, about 93%. And but there are some MathML features with unclear spec status that are causing failures. Sorry. So I extracted a list of some of them, which actually is related to what I just previously mentioned about the HTML and CSS compatibility. And I think in total, they represent 6% of the total test. I mean, the failures represent 6% of the total test. So if we were able to agree on these features, or if we decide to remove them from the spec, maybe we can improve the score. We have the opposite situation for Firefox and Safari, where they implemented MathML, but the new implementation details that are in MathML core maybe not yet followed by them. So just to give one example, for padding order imaging and out of flow, we have a lot of failures there. And also interesting metrics for Impurity is what we mentioned the other day was the browser compatibility data. So I extracted some of them that are related to MathML. And you can see that the result is pretty good again for the standard features in MathML core. The browsers implement all of them. I think Chrome already mentioned it's missing column span and row span. And WebKit is missing, I think, script level. But yeah, more or less have good Impurity for this part. And for Firefox and WebKit, you can see again that they don't have a very good implementation of the new CSS, math-related CSS features that we expose. And then we have also all this kind of DOM, which is good. It says there is only one test for foreign object, which is good also. But the bad part is about legacy MathML. So of course for Chrome, we don't implement any of them. But for Firefox and Safari, there are still some features that are here. We try to remove some of them from Firefox. For WebKit, it's a bit more difficult because Apple is not really willing to unship existing features. So for now, we're only experimenting this stuff under flag. Okay, so and just to conclude about Impurity, I'd like to mention that we have done some work in Chrome, in WebKit and Firefox, and we plan to continue working on that. And that's all, so I guess we can move to questions. I got one more.
How's the accessibility of MathML in this implementation and the plan for future accessibility support?
Yeah, so good question. So, well, I think I mentioned this in a previous BlinkOn, but for this one, I only give the update from May. So, well, for accessibility, Apple had implemented some, I would say, accessibility API for Mac. So that's what we implemented in Chrome too. We had the same for Linux about ATK. We also implemented the same, not the same, but the one that was existing for ATK. But for Windows, I don't think Microsoft has any plan, or maybe I'm wrong, but I didn't see anything about a platform API for Windows. So for now, we are just relying on, well, an existing API, which is exposing just the MathML DOM tree, and then screen reader do whatever they want with this DOM tree, which is of course not ideal for navigation and this stuff, but that's what we have for now. For Android, I don't have any idea what's the plan. So for now, we don't expose anything on Android. This is only for the native support. So I know that some people are also doing some more work to extend MathML and add some semantics to it and maybe improve the way screen reader can read it. But yeah, so that's basically.
Okay, we have another from the room.
Just wondering if you have any feedback on adoption by kind of popular mathematics software packages like MATLAB, Mathematica, in terms of being able to export content as MathML?
So yeah, so I know well, some of these software are actually using MathML, I think, so they're able to generate MathML, but personally, I don't know if there is any feedback. Maybe some of them are part of the working group. I don't know. Brian, maybe you know more about this?
I mean, we've had a lot of participation in the community group and the working group. We've done also a bunch of outreach. There's a huge community of tooling around this, just like there is for SVG, right? Like, so mostly I think the things are like updating a few definitions, and a bunch of that work has already been done so that they output sort of in the preferred MathML core way, as opposed to the legacy way that used some other approaches for things that didn't really align with the platform. They weren't well aligned.
I have another one from the room.
Okay. So, the whole project of trying to get Chromium to ship MathML again started with legacy layout and then was ported over to LayerNG. As the LayerNG was being developed, has MathML influenced LayerNG in some way or driving the development of LayerNG?
Yeah, so that's a good question. So, well, it depends. I'm not sure if we did a lot to move things in LayerNG, but at least I can give you two examples. Well, one of the things is what we discussed again in previous BlinkOns about stretch operators. Stretch operators, we have an issue where that we cannot provide exact min-max widths for them, so we only have to give an approximation. And I find it interesting because, currently we still have this issue in LayerNG. But for example, last week in the WebKit contributor meeting, I think Alan gave a presentation where they were mentioning they are rewriting the layout and doing a different approach that doesn't need to use min-max computation. They are not doing basically a layout for min-max computation. And we also had the same discussion with Chrome people, the layout team, that they have this idea of experimenting a new approach where they would perform layout in order to compute min-max weights. So I think there are some things that is interesting here. Probably we should have discussed this before, and maybe we would have the idea of using this layout, because I think using layout for min-max weights would be very useful for MathML. So that's something that can be interesting. The second example is everything that you mentioned that in the past we had. Actually, we didn't have any legacy implementation for MathML. So if legacy is used, basically, the MathML formula is just poorly rendered. That's actually very similar to what we have for the CSS layout API. So the interesting thing is, for MathML, we really want all the layout to happen with the new LayerNG and not with legacy layouts, otherwise we have a problem. And when we were trying to analyze which use case are failing with MathML, we actually found exactly the same thing that was found by the LayerNG team. So we have SVG for range object was missing. The multi-column, I think, was used on Wikipedia for the references. Sometimes people were putting formulas inside references, which is inside multi-col, so that was failing too. Our printing was failing. That was a discussion with API owner. So, well, I'm not sure the fact that MathML needs that was really pressing I don't know, Google developers to actually work on this, but I guess we were able to provide some feedback. I know sometimes we also got some further reports with MathML and, for example, multicore or this kind of thing, which were detected by MathML. And actually, exactly the same crash could happen with using CSS Alert API. So I guess that was maybe useful. And the friend the SVG friend object, I guess, was implemented because we were asking this for MathML too, as I demonstrated in the Babylonian demo.
Rick, go ahead.
First, congratulations, Fred. It's a huge accomplishment to get this to intent to ship. So thank you for all your work on it. On the adoption question, have you added a use counter so we can kind of all watch on Chrome status as the web starts to use MathML more?
In Chrome, I don't think we have one. But in Firefox, I know they have a use counter. But I think the thing is that it's used basically on Wikipedia. So you get a lot of things. But even if by default on Wikipedia it's displayed by CSS, it's replaced by SVG image or PNG image. So it's actually in the source code. So you have nothing in the source, but it's actually not displayed by default. So the use counter of Mozilla is basically counting them, even if they are not rendered. So, but for Chrome, maybe we could add one, but I don't know.
Brian, go ahead.
Yes, it's an interesting question, like, because it is a niche, right? It's not like, you know, maybe like Twitter or Facebook is probably not gonna use a lot of MathML in their code or something. Like lots of things that the average person goes to all the time. But for education, or I know I've thrown this out a lot of times, like if, heaven forbid, there were a pandemic and we wanted to share information that involved math, maybe it would be really good to be able to share mathematical text. So I think like my question is related to that, which is there, like today, prioritization is like not exclusively, but in large part, vendors have a responsibility to manage prioritization of these things, and like identifying those things and their importance is, I mean, it's no easy task, right? It's very, very hard. Who's to say that this thing is the thing that we should focus on or anything? But it does seem to me that there are three parts to the web platform. There's HTML. Okay, you could say HTML, CSS, and JavaScript, but I mean, in terms of markup languages, the HTML specification since HTML5 has included SVG and MathML. And both of those things are like weird also-rans that don't get the attention or the alignment that the other ones do. And I personally think it's really important for us to like fix that and make it so that we have one platform that moves forward together, that we make them increasingly less weird, so that, like, you know, a rising tide for one lifts the others too. And I was wondering, like, if I suppose this isn't a question for Fred as much as the rest of the room, is like, how can we do better with that? Like, just as an example, until we took up this effort, if you just tried to grab an element and say dot style background color blue, it would throw in MathML. Like, that's weird, right? Like, I mean, that's pretty well established. We know what nodes are and elements, and like, how do we make sure that we allocate some priority toward at least unweirding and making one platform, I guess, is my question. Or also, does anybody just fundamentally disagree that that's a good premise?
No, strong suspect nobody disagrees, but also we're about running out of time. So thank you, Fred.
Thank you.